Yes, hi guys. So let me continue from question number 6. Up to now we have discussed about what are the nodes, cusp, definitions, okay, then points of these are multiple points known as double points, the kinds of double points we're describing. In kinds of double points or types of double points we have discussed about when node will be there. What okay, the equation of the curve will represent a node, okay, or the double point will be a node. What would the condition for that? Okay, just describe again after taking question number 6 and onwards. So these questions will also tell us that how to find out that the given curve is representing a or double point is a node, double point is a cusp or a conjugate point or isolated point. So isolated point or conjugate point, when it is there, as when the equation given, okay, the curve given here or the double point is representing a cusp, that means we find out the equation, okay, by equating the smallest degree term equal to 0, okay, and from there we can find out what the equation of the tangents. The tangents are real and distinct, okay, then the double point will represent as a node, okay, distinct and real. Distinct means different, okay, curves are there. There are two curves which are passing through the that point, okay, double point, and at this double point, the two curves are okay, the two curves which are okay passing through this point and the, representing two tangent lines. Those two tangent lines are distinct. So what are the conditions that I have already described in the definition part of this? Now, sixth question onwards, I'll just describe it how it is a node, when it is a cusp, or what is the condition for conjugate points. Conjugate points are represented when the tangents are not possible, not they are imaginary. Okay, the values by equal to 0 or something. For example, equation of a tangent is there, tangents are not presented there, or the values of x and y are imaginary. Okay, the equation of the tangent is imaginary. Okay, no tangents are there. That means conjugate point will be there. Isolated point is there. That is distinct from the given curve. Okay, nearby curve, there are no other points found on the curve. So that means this isolated point is known as conjugate point because it doesn't have any tangent point nearby, tangents nearby. That is how tangents are imaginary or that is possibility of a conjugate point. Okay, that is one point. Just in case of node, then I talked about what are the species of node and cusp. Okay, first kind of okay cusp, sorry, types of cusp here. Now there are different kind of cusp. I described that there are two kinds basically. The first species single point. Single point is also of second kind. Single point of first kind. Single kind of second species. First species. In case of first species, it is a horn-like. Okay, it is a horn-like or keratoid type of cusp is there, in which there is if we draw a normal, then the two curves are just opposite to the tangent line. Okay, tangent is coincident. In this, tangent is coincident. Both the tangents are similar. Okay, so out of this, one curve is like this, second curve is like this. So when tangents opposite to tangent, there are two curves, and this is forming a horn-like situation. Okay, horn of an animal. Okay, so in that way, this is a horn-like situation that is known as first kind of species of single point. Okay, single point is there, but it is of first kind of first species of cusp of first species type. Okay, and if it is a big type of problem, I mean big type of cusp given, that is known as first or single point of second species. Single point of second species, then double point of second species first, okay, and double point of first species. We described that what are the conditions. I'll just describe that what are the node, cusp, and conjugate points. Let me take now question number 6. Brief introduction, because I just described in the introduction part that what are the cusp, node, and conjugate points. Okay, then these are the types of multiple points, because double points we are describing about. How the double point, the origin will represent a double point, and that double point we have to find out. Sometimes double points are, number of points are there, okay, those double points can be there, but out of them, if they are not satisfying the given equation, that means that point is not a double point. Okay, if it is satisfying, that point will be a double point. Okay, or that origin is to be considered that point, and then we will shift the origin to that point. So what the condition for that I'll just describe. Let me take question number 6. Now what does it say? It says that show that the curve y square equal to bx into tan x upon a has a node or a conjugate point at the origin according as a and b have like or unlike terms. If they have the like term, signs, or you may say like, a and b have the like signs, unlike signs or like signs. If they have like signs, then they will represent a node. Okay, origin according as this will represent a node, has a node or a conjugate point. Conjugate point when a and b have unlike signs, and it is a node when it is have like signs. This we have to prove. Now let me take question number 6 here. Question number 6 says that the given curve here. So let me find the equation. So equation of the given curve. So equation of the given curve is, for the equation here, okay, it is y square is equal to bx into tan x upon. Now this is a different kind of question, but let me take consider it as a function and then differentiate it with respect to x and y partially. That is a node or a, okay. So this is the equation given. Let me take this as the first equation. Solution here. Now if I take it as a function, let the function f x y is equal to this equation. It can be written from this, taking this step to this side. It will be y square minus bx into tan x by a, okay, equal to 0 here, because fx equal to 0, this will go out. But this function is equal to this. Differentiating, so therefore differentiating it with respect to x and y, del f upon del x. This implies that del f upon del x. So differentiating it with respect to x, what do we get? This is 0 in case of partial fraction, partial differentiation, and now this is to be differentiated. Now it has two functions. First let me differentiate with respect to x here. So this is only minus b tan x upon a as it is. X is 1 differentiation, b as it is, tan x upon a as it is, first function differentiation, second as it is, minus sign. Now bx as it is, differentiation of tan x upon a. Differentiation of tan x is second square x upon a, but this is a function of a function, so x upon a is again differentiated. X is differentiation is 1 upon a, multiplied by 1 upon a, that means b upon a. Okay, so this is del f upon del x. Second, let me take this second equation here, and if I find out del f upon del y, it will give us, this doesn't have any y term, this is only y, this is twice y. This is third equation. Okay, now let me find out del square f upon del x square also. So let me find out del square f upon del x square, again differentiating it with respect to x. So this is only in one term, this is in two terms. Okay, let me take this function in two terms. So this is minus b into second square x upon a, differentiation of this into 1 upon a, that means minus b upon a. Okay, now plus this, minus sign. This is to be differentiated. First step will be minus b upon a into x1 second square x upon a as it is, differentiation of this. Now second square x upon a is to be differentiated. So what it will be? Minus sign as it is, b upon a into x as it is. Differentiation of this, it will be twice second, it will be 2 into, let me write here, 2 into, let me write in the denominator, into twice into second x upon a. Now second x is again differentiated. Second is differentiated, second x into tan x. So it will be second square into tan x upon a into 1 upon a, because x upon a is again differentiated. Differentiation of secant x is secant x into tan x, but it is secant twice. First is differentiation of secant square, that means 2 secant x upon a. Secant x upon a is again differentiated by function of a function method. It will be secant x upon a into tan x upon a. Secant x upon a was already there, so secant x upon a again has come up, so it is secant square x upon a into tan x upon a into 1 upon a. That means this is minus b upon a square, because this is in terms of this multiplication. Let me write here into this function multiplication. Now this is del square f upon del x square. This is your, let me take third equation, sorry, fourth. This is fourth equation. Now let me find out what is del square f upon del x. Now del x del y. What does it mean? If I differentiate this function, del f, this one, again differentiate with respect to x here, it will be del square f upon del x del y. It is 0 here because no x. This is the fifth one. What do we get? Now if I, okay, for getting the double point, okay, for getting double points, for getting double points, for getting double points, del f upon del x equal to 0, del f upon del y equal to 0, and f equal to 0. This we have to apply. So here this is equal to 0, not really, but del f upon del x equal to 0, del f upon del y equal to 0 implies that del f upon del x equal to 0, 0 implies that from this function, this is equal to, it will give us, okay, so minus b into tan x upon a minus b upon a into x, okay, so equal into secant square x upon a equal to 0. That means x equal to, from this equation, 0 here, because x equal to this upon this, b cancel out, so minus a tan x upon a secant square x, tan square is 1 upon cos square x, this is sin x upon cos x, okay, so 1 cos x cancelled out, it will be sin x upon a upon cos x, that means tan x upon a, again because tan x upon a is there, secant square x a will come in the denominator, it will be 1 upon cos square x. If I multiply this by cos square x, because 1 upon cos square x in the denominator will come in the numerator, it will be, let me write here, tan x upon a into cos square x upon a. This means sin x upon cos, 1 cos cancel out, and so this is 2, sorry, sin x cos x. This is sin x into cos x upon a. So when this is equal to 0, that means this value equal to 0. So x will give us 0. Here x is equal to 0. Okay, so this question is giving us x equal to 0. Now second case, when del f upon del y equal to 0 and del f upon del y equal to 0, imply that y equal to 0. What is the point here? X 0, y 0. So 0, 0 is the point. Okay, now let me find out the 0, 0. So this function is giving us y square minus bx tan x upon. If I substitute this value here, 0, 0, so y 0, f 0 is satisfied. The equation is satisfied at point. So 0, 0 is the double point. Okay, so 0, 0 is the double point here. So let me now 0, 0 satisfies the equation, this equation 0. This is also x 0. This is 0. 0 equal to 0. That means satisfied. So at 0, 0, where it is? I'm sorry. Okay, 0, 0 satisfies the equation of the curve. Satisfies the equation of curve. given. The equation given, the curve, equation of the curve is this. If I substitute x0, y0, 0 equal to 0, that means it's satisfied. It means 0, 0 is the double point. Now we have to find out at this double point, what is the situation of the tangent here? What tangent, the value of the tangent. Okay, so that for that we have to equate y equal to 0, y is equal to 0. This means this is a conjugate point here. Y equal to 0, where y is equal to 0 or y equal to 0, 0 from this equation. Equating, or if I substitute the 0, 0 points. Now let me check that what the condition of this function. So at 0, 0 we have found out this point. Now this is 0. So what is the condition of this position? So if I find out this del square f upon del x square and multiply to del square f upon del y square, this is only 2. So del square f upon del y square, del square f upon del y square is equal to, from this equation, 2 only. This is 2 here. So what is the condition? This implies that if I find out del square f upon del x del y whole square, okay, is greater than or equal to, if it is greater than del square f upon del x square into del square f upon del y square, then it will represent a node. Okay, so what is the condition? Del square f upon del x square is here. What is the value here? Del square f upon del x square is this value. This is giving at 0, 0 point. At 0, 0. At 0, 0, if I substitute 0, 0 here, so this is minus b upon a, and this terms will become 0 because tan x is there, so it is 0. So therefore this implies at 0, 0, del square f upon del x square, this one, will give us minus 2b upon a. Why minus 2b upon this, b upon a minus b upon a? These two terms only will be there. This will be 0, the third term. So minus b upon a and minus b upon a means minus twice b upon a at 0, 0. So at 0, 0, if I find out del square f on del x here, the value of this is this. Okay, what about del square f on del x? This is 2 only. And del square f, upon del y square equal to 2 only, because at 0, 0 this doesn't affect. Okay, it doesn't change, I mean. It will not change here. So that value will be only 2. It means del square f on del y square is 2. Del square f, this is this value. Now, what is del square f on del x del y? 0 here. This is 0. So 0 is greater than the multiplication, that is minus 4 b upon a, because multiplication of these two terms, minus 2b upon a into 2, is a negative value. So now it is, if b upon a are the like terms, now it says if this is like term, then 0 is greater than this negative value. Like terms means b and a both are positive, both are negative, negative. That will not change this minus sign. Okay, so in this way 0 is greater than this. This value will be greater. That means it will represent a node then. So for node, 0 must be greater than the multiplication of these two terms. Okay, so let me prove here. So what is the condition here? So these two values are here. Let me write del square f upon del x square, del x del y, del x del y. This value is 0. Is greater than del square f upon del x square into del square f upon del y square, and which is here 0 is greater than, this value is minus 2b upon a, this one, into 2. That means this is nothing but minus 4b upon a. So if it is b upon a are unlike terms, Unlike means this is positive, B is positive, this is negative, or this is negative, this is positive. Then this sign will be positive. Then this value will be greater. So if it is greater and this is lesser, okay, in case let me take, so the condition is here, if B and A are like in sign, that means both are positive like terms, both are negative. If they are negative, B is negative, A is negative sign cancelled out, positive, but this minus sign will remain. It means 0 is greater than. So in this situation, okay, in this case, 0 is greater than minus 4 B upon A. It means it will represent a node, because B square minus 4AC is greater than, this value is greater than 0, or is positive, or we can say that this 0 is greater than this. B square is greater than 4AC. Okay, that means this value is smaller. So this 0 is greater, undoubtedly positive, 0 is greater than negative value. It's less than 0, negative. So this will represent a node. Hence, the double point 0, 0 will be a node, will represent a node. It will be a node in that situation. It says, sixth question, that if A and B are like, if A and B have like signs, similar signs, positive, negative. If A is negative, B is here. If B is negative, A is negative, minus sign cancel out. Okay, this is negative sign here. So it will be lesser value than this 0. That means this condition satisfied. This is for node here. Now, if it is, they are different sign, or A and B are unlike signs, it says an unlike signs, then it will represent a conjugate point, or a conjugate point at the origin if A and B are of unlike signs. Naturally, if A and B are of unlike signs, A is negative, B is positive, different sign. So this negative sign and this negative sign will become positive, then this value will be greater. And if, let me write here, if A and B are unlike signs means different signs, or different signs, or of different signs, then minus 4B upon A, okay, will be equal to minus, okay, 4 into, let me take minus B, and A is positive, so this is positive here, this is plus 4B upon A, which is greater than. So this will be, in that situation, 0 is smaller than 4B upon A. What is this condition? B square is less than 4AC. That will represent imaginary points, negative points. I mean that this value is greater than this. That means this will represent then conjugate points. So in that situation, when B and A are unlike signs, it will represent this term will be greater. 0 will be lesser. This will be positive here. Positive sign is greater than 0. That situation will represent a conjugate point or isolated point. Okay, so this is what we have to prove here. It will represent a conjugate point if signs are unlike of B and A. Okay, this is proved. So hence, for unlike signs, the 0, 0, the origin will represent a conjugate point. So this double point will be a conjugate point if A and B are of unlike signs, and if A and B are of like signs, positive, negative, then the negative sign will not change. That means B square will be greater than 4AC. Okay, from that equation, that will represent a node then. This is what you call question number 6. Now, 7th question let me talk about. Question 7 says, show that the origin is a node, cusp, or a conjugate point on the curve dash according as A is positive. If A is positive here again, 0 or negative. There are three conditions. If A is positive or 0 or negative. If it is positive, it will represent a node. If it is 0, it will represent a cusp. If it is negative, then conjugate. Again, the same type of question. Let me take question number 7. Here, equation of the curve is equation of the curve is okay. This is y square equal to ax square plus bx cube. Okay, so ax square equal to ax square, y square equal to ax square plus bx cube. Okay, this is the equation of the curve given to us according as A is positive. Now, if I find out value of y here, let me first find out dy dx and everything. So that will give us some points here, or we can just equate the smaller terms. Okay, to find out the tangents here. So tangents, if are distinct, real, then it will be a node. Let me find out that. Question number 70. So that the origin is a node. Okay. So let me find out. So equating solution here. This can be done in different way. So equating the smallest degree terms. The smallest degree term or terms equal to 0 to 0, equating the smallest degree terms to 0 to find the tangents, of the given curve, tangents at the given curve, tangents of the given curve or at the given curve here, at the given curve. So what do? We just find out these are the two smaller terms. So it means y square is equal to ax square. Okay, so y square equal to ax square. This implies that y is equal to plus minus under root a into x. This is ax square or a square x. Okay, ax square. So y equal to plus minus ax square, because this is equal to this. If I take them equal to 0, that means y square minus ax square equal to 0, or y square equal to ax square. So in this case, let me talk about if a is positive, it means it is represent two distinct real terms. Okay, right here. So here, this represents y equal to plus minus under root ax minus ax or plus ax. This here, this represents two distinct or real tangents. Let me take here. This represents two real tangents. Tangents are real. Okay, two tangents are real here, or equations are the real, and or curves are real here, and two tangents are real because y equal to plus under root this and minus under root this. Two real values are there. Okay, and if there are real values, real tangents are there, two different tangents, they are distinct also, and they are distinct. If I take a here positive, so this is a here, or y square equal to a x square if I say. Okay, so here y equal to plus minus under root ax. So if a is positive, because x, it will depend upon a. If a is positive, then square root can be taken out. If it is equal to 0, then y equal to 0, so it will represent a conjugate point to coincident tangents. Tangent will be coincident then. If a equal to, so, and tangents, and they are, or this point, they will be, let me write here, and they will represent, and they are distinct Mean two different tangents if A is greater than 0, A is positive. But then square root can be taken out. Then in that situation, two distinct lines will be represented by this y equal to plus under root ax and y equal to minus under root ax. If A is positive, okay, there were plus and minus sign are there. If A is positive, then these two tangents are distinct. That means that will represent a node. Okay, so distinct. If A is greater than 0, then y equal to plus under root ax and y equal to minus under root, because under root ax can be taken out. Square root can be calculated off under root a, because a is positive. So is positive value, negative value. So there are two tangents here, distinct tangents. So tangents were real, distinct now. So if they will represent a node. But two distinct tangents if are there, then it is a node here. So it will represent a node. So the origin will be a node here. Okay, so origin is node. And if we find out a differentiation of these 2 points, okay, let me find out the points here. What are those points? Okay, so that the origin is a node. So origin, we have to find out the point. We find out differentiation of these 2 points, then equal to 0, del f1, del f, del y, del, okay, that we will do. But this is tangents here. Okay, let me find out that origin is also there. If a is 0 and if a equal to 0 here, y equal to 0 here, that will be y equal to 0, so, or y equal to 0. So then identical tangent will be constant. Then tangents are coincident. That means it will represent a cusp. So that is a cusp here. So cusp, it will be a cusp, then it will represent it will be a cusp here. So it will represent a cusp because two tangents are same, coincident, but y equal to 0, y equal to 0, a is 0 here. So it is y equal to 0 plus minus 0 plus 0 minus 0. Doesn't matter, but coincident. Tangents are coincident, that means it will represent a cusp. Second condition, if a is negative, then square root cannot be cancelled, can be taken out. So in this case, this is imaginary. I mean y equal to x into I. So that means these tangents are imaginary. Conjugate point. It will represent a conjugate point here. So if a is negative, a is 0 here,